Hello, today we're going to go over my Excel simulation that for randomly generated points in a unit circle, the probability that those 4 points generated does not form a quadrilateral. And we don't count a concave quadrilateral. We're only talking about 4 points generating a shape that has 4 sides that basically look something like this. In this case, even though you can draw a concave quadrilateral, we're not going to count that. So what is the probability that 4 randomly generated points in a unit circle does not form a quadrilateral according to our definition? So I started out by, this problem came from brilliant.org, and the problem says that if we were to take 4 nails and we were to hammer them into a circular wooden board, and if we were to take a piece of rubber band and wrap the rubber band around the 4 nails, what's the probability that the shape does not form a quadrilateral? So if we were to wrap a rubber band around these 3 points, then it's going to form a triangle, not a quadrilateral. We started out by randomly generating 4 points using a random r for the radius and a random phi for the angle, basically polar coordinates. But what I found by doing that is that the points were generating using the polar coordinate system heavily clustered around the origin, and I decided to not use that method of generating points. Instead, I'm using the XY system, directly having a random X and a random Y, a negative and positive direction, but making sure that it's in the unit circle by putting this condition in there that X squared plus Y squared has to be less than 1. And if it's not less than 1, I simply throw it out. So 4 points that I generate, all 4 of them have to follow that rule, or have to be in a unit circle before I take them and test it. So once I generate the 4 points, I copy it in here. The macro does it automatically. I paste it into this little table here, and then I check for whether I have exactly 4 instances where the 6 possible lines generated by these 4 points, where the other 2 points are going to be on the same side of the line generated by these 6 lines. So in other words, if I have 4 points, I'm always going to have 6 lines, and I want to make sure that 2 points are always going to be on the same side of the lines in exactly 4 instances. And if it's anything other than 4 instances, if there are 3 instances of that happening, then I know I do not have a quadrilateral. If there are exactly 4 instances where 2 points are on the same side of the line, then yes, I know that it's a quadrilateral according to our definition. And so here's the check. Slope, I got my b, which is the y-intercept. This is the check here, making sure that if both of these are true, then it gives me a 1. Then I know that those 2 points are on the same side of this line CD in this case. And I know it's a quadrilateral if the sum of these 6 checks equal 4. If it's equal 4, it's a quadrilateral. If it does not, then it's not a quadrilateral. Alright, so the macro goes in there and basically just tabulates. I keep testing these 4 points, and it keeps testing these points to see if, and it tabulates it right here in column Z to see if it's a quadrilateral or not. Let me just run a quick example of just using 100 samples, 100 sets of 4 points, and see what we get. What I find is that running a small number of points, like 100 points, doesn't really give me the result that I'm looking for. The larger the sample size, which is law of large numbers, essentially, right? The more points you run it, the more accurate it's going to be. So in this case, when I run 100 points or 100 sets of 4 points, 21% of the time it's not a quadrilateral. But when I run these larger sets of points, when I run up to 5,000 points, in this case I run 10,000 points, I find that it probability clusters around, it averages about 29.5, 29.6% of the time that 4 randomly generated points in a unit circle is not a quadrilateral. See, if you just do an average of these runs of large amount of points, I get about 29.6%. That's my answer. I'm sticking to it. I had a lot of fun building this. Thanks for watching. Be sure to check out my other videos. Bye for now.